Welcome to Introduction to Chemical Engineering. As I introduced myself in the last video, I'm Krishnan Chittur, University of Alabama, Huntsville. What I'm going to do now is to give you kind of a bird's eye view of the course, of the products and concepts you're going to cover in the physics, chemistry, and biology module. So that's our objective. And as I mentioned in the last video, we're going to start with a product, and I'll tell you some of what those products are. We're going to take a look at the concepts from the enabling sciences that are somehow involved and important in those products, for example. And then take a look at the role of the chemical engineer in using, understanding the sciences in that science, for example, and then understanding how the product is actually made. So that's the way we're going to approach it. In chemistry, we're going to take a look at, I would say, two products, even though there could be multiple products within each of the classification. The two products are going to be fuel, which, I mean, all of us use fuel in one way or another, whether it is gasoline, diesel, or heating oil, or some other form of fuel. We all use fuel. And chemistry of those fuels and how the fuel, what the fuel properties are, how they burn, and how we get how we get heat or other energies from those fuel is something that we really do need to understand. The second product is I just call them sensors, if you will, film, if you will, that are used in cameras. There's a lot of chemistry. The films that we're going to talk about, the two types of films we're going to talk about are the conventional silver halide films. It is still used in Hollywood, for example, to make these very high resolution type movies and so forth. Though the gap between the digital film and the film silver halide films, that is actually narrowing, but still, these two types of films are actually used. So we're going to ask the question, what are some of the chemical concepts we need to understand or to know in order to make and use these products, and what is the role of the chemical engineer in these products? This is what we will talk about in the chemistry module. In the physics module, we'll talk about essentially, I would say one product, as it were, and that is airplanes, one of my favorite products of all times. It's just amazing when you think about it. Such an object, so much heavier than air, is able to fly, and for hours at a time, for example. How does that do that? How does it do that? What is the principle from the physics, from physics, that we need to understand to see, to appreciate how a plane takes flight and flows for a long time? A related concept in the physics we'll take a look at is about materials. So, for example, is there a reason why most of the airplanes today are made of aluminum, for example? Why not stainless steel or titanium or wood or something like that? Though there were some airplanes partly made of wood at some time. But how do you choose materials with different applications? So there are some physics concepts that we need to understand. In particular, so we'll talk about properties of materials, how do we test them, and some of the issues leading to choosing materials in different applications. And we'll talk about an important principle called Bernoulli's principles, which will allow us to understand lift for airplanes and so forth. So that's going to be in physics. In biology, we're going to talk about two very, very important products. One is insulin, and some of you might know what that is. It's a protein. It's a short protein or a peptide. It is used by diabetics. There are certain diabetics who do not make insulin or do not make sufficient amount of insulin. And if they don't make insulin, then the glucose cannot be transported from the bloodstream into the cell. So they will essentially starve themselves. So insulin is something of a product that is now made in large vats and factories and so forth. So we'll take a look at what insulin is, what some of the functions of insulin are, and how that is actually made, and in particular, how critical chemical engineering is in order to make insulin. The second product we're going to talk about is penicillin, which is sort of the wonder drug that for World War II that is still used for treating infections, bacterial infections. people used to die of ordinary infections. There are stories about how more people, I think before World War II, died in battles of infection rather than actual battle injuries. So penicillin, and he noticed that these are completely two different types of molecules. They're still molecules made of materials that you can sort of go back and understand them in chemical terms, but they're very different. At the same time, they are very, very important products, and chemical engineering has had a substantial role to play in the manufacture, in the design of the equipment to manufacture, purify, and so forth. So what we've done here is to essentially give you an overview of the products in chemistry, biology, and physics that we're going to take a look at as we move along. You notice that I don't have a module about mathematics, and again I'll remind you, we will be doing mathematics, but mathematics will be sort of integrated in different portions of these different modules as we move on. So come along with us as we look at different products and try to understand the enabling sciences in these products and the role of the chemical engineer.